Cool, so today we're going to look at how we calculate linear regression, and this is a way of making your lives a little bit easier when it comes to plotting a line of best fit. Up until now, you've taken your data, you've calculated the mean of all your x values and the mean of all your y values, and then you found those 2 points, one on the x-axis and one on the y-axis, and you've put a point where those two meet, and then you've had to organise your line of best fit by eye, trying to get all of the points to be equally spread on either side of the line. And that's quite a tricky thing to do. So for today's lesson, we're going to look at how we can get our calculators to draw that line of best fit for us, and actually give us the equation of a line as well. So just quickly, I want you to think, what is the equation of a line? How do we write it in algebraic form? We talked about it very briefly last lesson, so see if you can remember now. So if you just thought to yourself that the equation of the line is y equals mx plus c, fantastic. We might have thought of it as y equals ax plus b, that's another way that people say it, and that's absolutely fine and will actually be much more useful to you for this lesson. In this case, when we talk about m, that is the gradient. So that tells us how steep the line is. So in the case of the graph that we've got here, the gradient is 2. So that means for every one step along the x-axis, we go 2 up on the y-axis. That's what that tells us. And the c is the intercept. So here the intercept is 1, and that tells us that the line crosses at the point y equals 1. So that's what those two bits of information tell us. So how's that going to be useful to you? Well, for now, what I'd like you to do is try putting this into your calculator. So remembering to put this data into your stat menu. I want you to try and calculate the correlation coefficient first of all. And if you're using the calculator on the screen, on the computer, don't forget you're going to need to go back to second, 0, scroll down to diagnostics on and hit enter twice before you start doing this. And then I want you to try and plot a graph, see if you remember how to plot a graph. So, pause the video here, give all of these things a go. Once you think you're done, start the video up again. Okay, so you should have found yourself going to your calculator and going to stat first of all and edit, and then putting your data into these two columns here. So let's see what we've got. We've got 11, 10, 15, 17, 12, 14, 20 and 19, and these are all the ages here. Then we've got the minutes per day spent watching TV. So we've got 60, 55, 15, 10, 40, 35, 0 and 10. Now, because I'm using my calculator on the computer, I'm going to need to go to second. It will let me, there we go, 0. And then I'm going to scroll down until I get to diagnostics on. Should be around here somewhere. Here it is. I'm going to hit enter twice, and then I should be able to go to stat, calc, and down to my lin reg and hit enter, and here we go. So my correlation coefficient is down the bottom here, negative 0.95. So it is strongly negatively correlated, okay? So this is interesting. I should be imagining a graph now that's going downwards like this. Let's see if I'm right. So I'm going to go to my stat plot and I'm going to check. Currently they're all off. I want this first one to be on. Enter. I'm going to hit enter on there. Now it's on scatter plot already and it's picking up L1 and L2. So I'm going to go to graph. nothing's showing. Remember, if nothing shows, we hit zoom and we go down, or you can just hit the number 9 button to zoom stat. And here we go. We've got our graph that is going downwards like this. Okay, once we've got to this point, there's a couple of things that we can do. So let's have a look at what we can do. We can draw ourselves a line of best fit. So I could calculate the average age, I could calculate the average number of minutes spent watching TV, I could put a little point, it'll probably be somewhere around here on my graph, and then I can carefully line up a straight line so that I have the same number of points on each side of the line. But that can be subjective, the placement can be subjective. So someone might put their line of best fit here. Someone else might decide it's better off here. So you can see there's a bit of a difference between those two. And you'd end up, when you come to make predictions, as we're going to do in a minute, you'd end up with quite different answers depending on where you put your line of best fit. So instead of doing this, we use our calculators to draw ourselves a line of best fit, to give us an equation for our line of best fit. We can then go on to use this equation to easily make predictions, even for values that we haven't included on our graphs. So let's have a look at how we do this then. I'm just going to, on my calculator, go back to stat a second, across to calc, and back down to this linreg here, and hit enter. Now, I've already got it up on the screen here from before. You can see that my A value here, these are ones that we haven't used yet, the A value is -5 point, and then around about 8 if I round up. We've got a B value here of 113.65. Now, these two values actually tell me my M here, my gradient, and my C, my intercept. So A is the gradient and B is the intercept. So how do we use these? Well, we've got our value for M, our value for C, and I can put it into an equation like this. Y equals -5.80x plus 113.65. What this tells me is that for any point on the graph, I can predict my Y value, my number of hours spent watching TV, by doing -5.80 multiplied by my value of x, my age, plus 113.65. And that will give me the number of hours spent watching TV for that age. Another clever thing is we can actually take this equation and we can put it into the Y equals on here. And so I'm going to put it in, remember to use this little negative here, -5.80, and then we need to put in an x. Now you'll find your x here, and it's green, so I need to hit this alpha button for x, and then plus 113.65. Enter. Then I'm going to go back to graph again, and it should draw me my line of best fit. And there it is. So you can use this if you sketched a graph for the exam. You can actually use this to help you place your line of best fit as accurately as possible. But another clever thing you can also do with it is you can make predictions. So you can substitute any value of x into the equation and find a value for y. Remembering at this point that x is whatever we have in our L1 list, that's age for us at the moment, and y is whatever we have in our L2 list, which is in this case the minutes watching TV each day. Now obviously when we do this, these are just estimations, they're predictions. If you have only a moderate correlation, these predictions aren't going to be very accurate. But the closer to perfect you get, the better these predictions are going to be. So here's my equation, and here's my question. How many hours of TV would a 6-year-old watch per day? So a 6-year-old, that's age, so I'm going to replace this value of x with the value 6. So I'm going to do y equals, remember y in this case is the number of hours spent watching TV, negative 5.80 multiplied by 6 plus 113.65. If I put that into my calculator, I get 78.85. So I would predict that a 6-year-old would watch 78.85 minutes of television per day. Obviously, this is probably not accurate, but according to my line of best fit, that is the prediction. So extrapolating, stretching out from the data that we've got, this is our prediction. Okay, your turn. What I'd like you to do is try page 230 to 232. Exercise 5G spans over all of those pages. For each of them, I'd like you to follow it carefully, making sure that you are answering the questions on the page. Your homework this week is to revise for a test on Thursday morning. This test is going to include questions that cover everything that we have done in the last term. So Edpuzzle is your friend. Make sure that you're watching through videos, reminding yourself of what you've done and how to use your calculator. You will need to be able to use the calculator. For those people using it on their laptops, you will be allowed to use it on your laptop, but you will not be allowed to have anything else open. Only the calculator.